You're here because you want to master mole calculations from chemical equations with a University of Cambridge graduate. This is actually part 6 of our mole concept lecture series. If you want to watch our previous lectures or you want to watch further mole concept lectures, be sure to check out our playlist or check out our link in the description below so that you can further watch these videos. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. A very important skill you need to know is how to do your calculations from an equation. Okay, usually you need to get the equation first, alright, by deciphering what kind of reaction it is, what products are formed, and balancing the equation first, right? And calculation from equations is very simple. Okay, the chemical equation already tells you the mole ratio of the reactants and the products in a reaction. For example, if you take a look at this equation here, this means that for every 2 moles of hydrogen gas, right, and 1 mole of oxygen gas, you will get 2 moles of water that is produced. Okay, it's in a ratio, right? So it's not really in an absolute format. So if you have 0.4 moles of hydrogen gas reacting with 0.2 moles of oxygen gas, then you get 0.4 moles of water that is produced. It's just a ratio, right? And I like to liken this like a cooking recipe, right? Where you put in a certain amount of ingredients inside and then you get a certain product. Okay, let's say you're baking a cake, for example, and you put like 1 bag of sugar and 2 bags of butter and all that, and you get 1 cake, right? But if you lessen the amounts, right, then you'll get it proportionately, right? Let's say you lose like half a bag of sugar instead, then you get half a cake, right? Or it'll be half as sweet, for example, right? So it's just like a cooking recipe. So let's take a look at some examples of how we can apply this concept. So let's say we want to calculate the mass of water produced when 0.5 grams of hydrogen gas is burnt in oxygen, and they very nicely give you the equation. So again, if you ever don't have the equation, right, the first step is to write the balanced equation. Right, always write the balanced equation, and then the second step I always recommend, okay, is to write out all the details from the question. So they give you 0.5 grams of hydrogen, right? So I'll just put this, and then they ask you to find the mass of water. So I'll just put a mass question mark, right? So from here, okay, we have this as a starting point. So why not we start from there, right? We can find the number of moles of hydrogen gas first, right? And we can actually take 0.5 divided by 1 times 2, and this will give you 0.25 moles. Okay, and from here, since we have an equation, we actually have a mole ratio. So we can find the number of moles of water next by a mole ratio. So we always put the thing that we are trying to find as the numerator for the ratio, and the thing that we know already, which is like hydrogen gas in this instance, at the bottom, right? We know this ratio is actually in a 2:2, which is 1:1. So the number of moles of water, okay, is equal to the number of moles of hydrogen gas, which is 0.25 mole, right? And from there, we can find the mass of the water. So now that we find the number of mole of water, we can find the mass of water by doing the conversion as we learned from the previous lecture, the previous video, right? So this is just the number of moles of water times the molecular mass of water, which is just 0.25 times 1 times 2 plus 16. This will give you a value of 4.50 grams. You can leave it in 3 sig fig. Okay, so let's take a look at another example. So magnesium here reacts with hydrogen chloride according to this equation over here, right? And they very nicely give you the equation, which is always the step 1, right? And then they're asking you to calculate the mass of hydrogen chloride, HCl, required to make 20 grams of magnesium chloride. So again, I would consolidate the information over here. So, right, so we know that we need to make 20 grams of magnesium chloride. Okay, this is most likely our starting point. And they're asking you for the mass of hydrogen chloride that we need. So this is just mass, question mark. Okay, so the thought process is as follows. Okay, I have the mass of magnesium chloride. Okay, I'm going to find the number of moles of magnesium chloride. Okay, and then I'm going to use the mole ratio to find the number of moles of hydrogen chloride, and then from there I can find the mass of hydrogen chloride. So actually I can construct like a rough thought process flow for a mole calc question. So it doesn't even matter what values they give me, right? As long as I know this process, right, I can go step by step to find the final value. So let's get the number of moles of magnesium chloride first, right? So they gave you 20, they say you need to produce 20 grams, right? So you need to take 20 divided by the MR of magnesium chloride, which is 24 plus 2 times 35.5, which is equals to the 0.2105 mole. Or intermediate working, I like to leave it in 4SF. And then let's do a mole ratio. So this NaCl to N magnesium chloride. So we actually know the mole ratio is actually 2:1 from the ratio over here from this equation. So the number of moles of HCl, you have to multiply it by 2 here. Okay, this will give you a value of 0.421 moles. And from there, we can find the mass of HCl needed, which is 0.421 times the MR of HCl, okay, which is equals to 0.421 times 1 plus 35.5 opening bracket. This will give you a value of 15.4 grams. Okay, so I want you to pay attention to the whole thought process instead of just focusing so much on the answer itself, because the thought process is what helps you learn. Okay, so let's take a look at this. Nitrogen gas and hydrogen gas reacts together to form ammonia gas, and they give you this rough equation. Okay, they ask you to balance the equation above and then calculate the volume of ammonia gas produced when 12 dmq of hydrogen gas is used. Okay, so first balance the equation, right? If you balance the equation properly, you know there's 2 n's on the left, so this has to be a 2, and then there's 6 hydrogens on the right, so this has to be a 3 over here. Right, then next, after this, we want to consolidate the information. So we consolidate it and we say that they give you 12 dm cube of nitrogen gas and they want you to find the volume of ammonia gas produced. So volume question mark. Okay, so this is a very interesting case, okay, because we have all gases, right? So here's a little rule that I like to teach, okay, is that only for gases, right? When you have gases in the equation, right, and you're comparing gas to gas, okay, this is only for gases, your volume ratio actually equals to your mole ratio. Okay, just remember this rule. Volume ratio is equal to mole ratio only for gases. Okay, so actually the volume of your ammonia relative to the volume of nitrogen gas, okay, is equals to the number of moles of ammonia divided by the number of moles of nitrogen gas. Okay, and we can find this mole ratio from the equation. So from this equation, this is just 2/1. So from here, the volume of your ammonia, right, is just 2/1 times the volume of nitrogen gas, which is 12. And you get a value of 24.0 km3. Alright, so let's take a look at one more example over here. So sulfuric acid and sodium hydroxide can react as follows. So they give you an equation very nicely. Okay, it looks balanced as well. So then calculate the relative formula mass of sodium sulfate and sodium hydroxide first. Well, this doesn't really require the equation. Okay, so for part A, they're asking you to find the MR of each of them. So let's just calculate it from scratch, right? So there's just 2 times 23 because there's 2 sodiums plus 32, which is sulfur, plus 16 times 4 for oxygen. This will give you a value of 142. Usually for MR, we don't have a unit. Okay, so take note of that as well. Then the MR of sodium hydroxide, okay, equal to 23 plus 16 plus 1 for each of the elements. This will give you a value of 40. Okay, that solves part A. Then part B, they say, what is the mass of sodium sulfate that can be formed from 40 grams of sodium hydroxide? So let's consolidate the information. That's number 2. So they're finding the mass of sodium sulfate, so I put mass question mark, and then 40 grams of sodium hydroxide. Okay, so the rough flow is this, right? We are given the mass of sodium hydroxide. We can find the number of moles of sodium hydroxide, and then we can find the number of moles of sodium sulfate by a mole ratio, and then get the mass of sodium sulfate at the end. Okay, so this is the whole rough process. You realize I'm just converting from mass to mole and then mole back to the thing I'm trying to find, which is mass, right? This is a very common theme in a lot of your calculation questions. Okay, so let's find the number of moles of your sodium hydroxide. Okay, the number of moles of your sodium hydroxide is just the mass of your sodium hydroxide given divided by the MR of sodium hydroxide, which in this case they give you 40 grams. So this is actually just 40 divided by 40, which equals to 1 mole. Right, and then we use a mole ratio. So number of moles of sodium sulfate is to number of moles of sodium hydroxide. From this equation over here, you realize this is just 2:1, or 1:2 here. So it's just 1/2. Right, so the number of moles of sodium sulfate is just half times 1, which is 0.5 moles. And then we can find the mass of sodium sulfate, right, which is just 0.5 times the MR, which we already calculated beforehand. We want to use the part A if we can. So it's just times 142. So give you a value of 71.0 grams. Final answer. with 3 significant figures. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.